Hello and welcome to Building Smarter AI Agents, How Faster Iteration Drives Better Results. Today's webinar is sponsored by Neon and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we have a few housekeeping items that are going to help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know if you have any technological issues with audio, video, or slide advancement. A browser refresh will fix most of those, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a PDF in there for shipping faster with Neon. I encourage you to access those resources now and share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section as well. Just scroll to the bottom and you'll find the link with the details there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. All right, with that housekeeping out of the way, let's get into today's fantastic session. So AI agents hold incredible potential, but their usefulness depends on the speed and quality of iteration during development. In this session, we're going to explore how to build smarter agents by accelerating building cycles. You'll discover tools and processes that can help you streamline your AI workloads or workflows, including Wordware, which is an IDE for prompt engineering, and Neon, a serverless Postgres database. And there are going to be a lot of demos. And to have that conversation and run those demos, I'd like to introduce our speakers. We have Ralph, who's Senior Developer Advocate at Neon, and we have Robert, who's co-founder and CTO of Wordware. So let me bring Ralph and Robert on. Gentlemen, welcome. Thanks for being here.
Hi, everyone.
Good morning. Great to be here.
All right. Well, Ralph, I'll turn things over to you to get the conversation started.
Awesome. Yeah, very excited to be here. Well, let's get started. I have a couple of questions for you, Robert. So can you tell us a little bit about what Wordware is and what motivated you to build it?
For sure, yeah. So I guess starting a little bit further back, me and my co-founder, we met 10 years ago studying machine learning at Cambridge, and friends for a very long time. He actually went to San Francisco, built his first company using GPT-2 and BERT, which was really early in the space, was trying to augment human memory, a lot like these always listening devices that we're seeing, all these pendants that are coming out nowadays. And that was a real struggle. And a lot of that struggle came through the fact that the models weren't quite ready, but also the fact that you're kind of doing all this prompt engineering in the code base. I built self-driving cars for 5 years, and one of the things that we found that made our development way better was to tighten that feedback cycle. And so I led a team doing offline perception, where we tried to annotate every single vehicle, pedestrian, lane, sign in the road scenes in every drive that we took, so we could get a lot more data from every drive that we took, and we could tighten that feedback cycle, learn more from every iteration. And I think from any software or any product, you get a better product the tighter you can make that feedback loop. And so that's kind of one of the foundational things from our background that led to Wordware. The other more concrete thing is about 18 months ago, when we kind of pivoted into AI, or pivoted back into AI from our previous company, we were really exploring, what does it mean to build an AI agent, and what can you do with these LLMs? And so we built them. We spent a bunch of time building agents from scratch using, we read all the papers like Toolformer, like React, we LangChain, and we learned the kind of what it means to treat these LLMs as a reasoning engine rather than as a retrieval engine. I think at the time, a lot of people were thinking about LLMs as how can we build a better Google, or how can we do chat with our docs? And we were far more excited by the fact it can kind of think and reason and like do stuff that has never been possible before. We also kind of spoke to kind of hundreds of people who were building with AI. So everything from tiny startups in London who were sort of trying to use AI to augment the planning permission process to like build new buildings, to the kind of calm.com founders who are trying to build like a AI therapist and kind of improve people's lives that way. And there were two really important things that stood out. The first is that agents are just prompts. So no matter what people say about fancy things like inter-agent communication, at the end of the day, all these agents, they're just a collection of prompts. But how you craft that prompt is so important. When we say inter-agent communication, what you mean is you're taking the output of one prompt and putting it into the context for the next prompt. And you also need to have the instructions from the user. You need to have, the input from the user. You need to have the instructions. You need to have probably some data that has been retrieved from some knowledge bank to give the right context to the model, such that it can make that next step in the reasoning process. The other lesson from kind of talking to these hundreds of people, and this is really where the feedback cycle comes in, is that most agents that we want to build, the engineers are not domain experts. And so you have this very, very slow feedback cycle where the engineers will be writing prompts in the code base. They will then be showing the outputs of these agents to their PM or their CEO, whoever's the person that knows what good looks like in this space. And they'll get very fuzzy feedback. It'll be like, it's good on X, it's bad on Y. The vibes are off. Now, I don't know how many people in the audience are engineers, but I can speak for myself that, as an engineer, we don't like vibes. We like kind of clear requirements. We like scores that we can make higher. And it leads to this kind of very frustrating, very slow feedback loop where, the engineer kind of takes that feedback, goes, okay, I'm going to like optimize towards this very fuzzy goal, tweaks the prompts a bit, shows the output to the PM, gets another sort of fuzzy feedback. And it feels to everyone like you're doing a bit of a random walk. And you're not really going monotonically in a direction that's better. So that's what we want to solve. We want to solve this, like, why can't you build a good agent, especially if you're not a domain expert? And maybe to give it a kind of more concrete example, to an engineer, like a good cold email and a bad cold email, they look kind of the same. But to an SDR who's been doing that for a few years, there's a really big difference between the one that's going to convert and the one that's just like meh. So that's one place where if you can put the person who knows what good looks like in the driving seat, they're able to iterate and kind of whisper to these LMs to get them to output the right thing and get these agents to work really well. So we basically thought, okay, if prompting is the new programming, based on everything we've seen, what should the tools look like? And we thought from first principles, and we said, okay, what we need is the flexibility of natural language with the structural programming. You need to be able to kind of constrain this weak AGI to make it kind of expert narrow AI. And that means you need kind of looping and branching and type systems for structured outputs. You need to have modularity so you can make components that are reusable and repeatable. But you also need to be able to leverage the kind of the intelligence that is the LLM and put it in an interface that's familiar and friendly to kind of non-technical people. And so that's what Wordware is. It's a prompt-first programming language wrapped in a web-based IDE that looks and feels like Notion. It allows you to build up these complex chains of prompts that are the underpin what an agent is, and combine, the prompting with the logic, with the code execution, such that you can build these really powerful reasoning engines, these really powerful autonomous agents. And yeah, that's kind of, I guess, a long answer to your question, but yeah, Wordware is a place to build AI agents with the goal of bringing your engineering team and your product team together so you can build something faster and better.
I really like always to hear about the backstory and the motivation behind like what problem you guys are solving, right? And I like this idea. So if I get it right, like you guys build these agents and chain them, but you're thinking about them as tools that can reason or agents that can reason, as opposed to agents that can just output a certain result or like answer some questions, pretty much.
Yeah. So actually, at the end of the day, what you want is something that can just give you the answer you're looking for. And I think one of the big downfalls of a lot of the the general agents is that, they can try and work out what to do every time, but they'll end up not necessarily aligning with what you want. So you can imagine a general agent, and you'll say, okay, write a blog post, and it can go and it can figure out, okay, how do I write a good blog post? And it will, maybe it does some research on the internet and like what makes a good blog post, and then it like thinks of a topic that could be good, and then it like creates a hook and it writes the post. But it's got to figure that out every time, and the chance of it actually succeeding right now is quite low, because even if every thought is like a 95% accurate thought, by the time you've had 100 thoughts, you've basically got a very, very low chance of that still being a good sort of chain. Whereas what we do with Wordware is we can say, okay, don't try and build a general agent. Build a narrow agent. Build one that you can say, this is a blog post writing agent. And when you're writing a blog post, you first, and you take in a topic and you output a high quality blog post. So you can kind of treat an agent like a function in kind of classical software. And the input is this like topic, and the output is the blog post. And to do that, you need to first do the research, then come up with a hook, and then write the outline, and then critique that outline, and then refine the outline, and then write the introduction, then write the conclusion, then write the rest of the blog post, and then critique it again. And all of this, it takes a little bit more time, but what it means is, it takes a little bit more time to create, but what it means is you're able to really align that agent with what you want. And so in the bit where you're creating the outline, you can be like, oh, generally our blog posts have like these 4 sections. And when you're having the bit that actually writes the content, the copy for the blog post, you can be like, these are the kind of tone of voice that we normally use, or you can include actual examples from your blog and make it very much like grounded on what you want.
That makes tons of sense. So you want this set of specialized agents that can do like just one specific task, but do it really well, and then make them somehow communicate and collaborate to get the final output, like constructing a team, pretty much, right?
Exactly,
So
exactly like a team. And it's right now, it's not so much about like having them communicate and collaborate. It's more about almost having, what is the SOP you're trying to automate? What is that standard operating procedure inside your company that is something that you feel could be done now by AI? What would you delegate to an intern if you had 1,000 interns? That's.
So you mentioned that you built Wordware not just for engineers, but for everybody. So not necessarily for people who are domain experts, you mentioned. But I was wondering, what was the main difference between Wordware and other agentic frameworks as well that are out there that are destined to engineers mainly? But what else is different?
Sure. Yeah, I think there's 2 big differences. One is that so on one end you have the code-based agentic frameworks, things like LangChain, like CrewAI. They're kind of designed for developers and used by developers. On the other end, you have these kind of AI orchestration frameworks that are very like low code, and they tend to be sort of linear workflows, or they care a lot more about the integrations and the logic than about crafting really good prompts. And so the low code tools, they're great for kind of getting started, but then you very quickly hit a ceiling. There'll be something you want to do that you can't do, just because if it's a flowchart, adding a loop in a flowchart becomes really very difficult. Adding a loop inside a loop in a flowchart is extremely difficult. And then if you've got branching inside that loop, inside that loop, inside that flowchart, you basically end up with too many dimensions that are not possible. It's like not even possible to express that on a 2D canvas, at least not without making your head hurt in a really difficult way. The other part on the sort of the code tools, we want to have as high a ceiling as these kind of code-based tools. And so you should never feel in Wordware that you're limited by the platform. You should always feel that, oh, actually I can do everything that I'd be able to do in raw code, in LangChain, but it's in an interface that is actually designed from first principles for this. It's when you're crafting a prompt, it looks like you're editing a document, and that's a much more natural place to write long kind of text than a code editor that's designed for structured syntax with curly braces. And then more kind of concretely on you kind of called us an agent framework. We kind of think of ourselves as an LLM orchestration framework. So you can be building kind of simple workflows, you can be building complex agents, but it's the actual end output is the same. You're trying to automate a unit of work. And so Crew AI is based on this AutoGen framework from Microsoft, where you have different agents that have personas and they talk to each other, and each different persona can use different tools. It can be quite effective. It can also struggle from this sort of unbounded general nature, where you end up having these different agents, like the QA agent talk to the software engineering agent that talks to the PM agent, and they just end up having a long conversation, and no one ever wants to do anything. Like it's a bit like dysfunctional teams sometimes, where it's just like I'm going to delegate to this person, and then this person's going to delegate to this person, and no one's like, I'm going to do the thing and actually make it good. So I'm not yet sold on these AutoGen style agents. I think they will be really useful once they can delegate to narrow agents, and I think that's where the future will go. You'll have narrow agents that are built on something like Wordware that are orchestrated by higher level agents that will also be orchestratable on Wordware. But we're focusing on actually building useful units of work currently.
There are so many things that I want that you mentioned that I think are interesting, because you mentioned loops and then inner loops, and you mentioned also branching, but I wanted to understand what you meant by branching. Like at Neon, branching is something different. Okay.
Yes.
For developers, branching it might mean another thing. So I was just wondering what you meant there.
So by branching there, I meant like if else. So if I want to take this path or this path, and I guess versus Neon's branching, which is more like Git branching, where you're like, okay, I want to like take a
just
copy
and make it clear to the audience. Like, okay, so branching in this case is just having a choice of doing different tasks depending on the clause. Okay, so I think. Well, the first time I heard about you guys was on Twitter, and I think you guys went kind of viral overnight, and I wanted you to walk us through that experience a little bit, and how do you guys handle that?
Yeah,
from a technical perspective, and also from the rest.
We like to dog food Wordware, and I guess dog fooding, if you're not aware, is the process of like using your own product to like internally, such that you really understand how your customers would be using your product. So we use Wordware to build things with Wordware. These can be AI agents. Sometimes they're really useful. The one that went viral was just a fun one. So this is an agent that would take your Twitter feed, and it started by giving you a personality analysis, like a bit like a horoscope. It would talk through your strengths and weaknesses, and your love life, and it would also roast you. And that little roast section people really liked. So we moved the roast to the top
somehow.
And people really liked being slated by an AI. I was like,
maybe you can just show us.
That works. So so actually, I did prepare this a little bit earlier. But basically, you can take someone's Twitter handle. In this case, we're taking our host, and you can go to twitter.wordware.ai, and then you can click discover. And because I ran this earlier, it's not kind of scraping your tweets, but it only takes a few seconds. And then I didn't switch tabs. Let me switch over here. So I can feed in the Twitter handle and click discover, and this will just run straight away because we've already cached it in our Neon database. And it roasts you. So it says, "Congratulations, Ralph. You've managed to turn your Twitter feed into a shrine of databases that's about as exciting as what you tweet."
Pretty much. That's a good criticism.
Postgres is so intense. I'm surprised you haven't tried to marry us SQL query yet. It was kind of harsh, but people love this. We went viral to the point where things were breaking, and we're like a fully serverless company. Everything you don't expect your infrastructure to start falling over. But like it was various different things that were falling over. So it was, the scraping API couldn't handle the rate that we were getting requests. We had not optimized our database queries at all. So they started hanging. It's not at all Neon's fault. This was just like we were doing some extremely inefficient stuff, and that led to the database hanging. And also we hadn't turned on auto scaling, such as on like 0.25 of a CPU. And it was like, oh, why is it suddenly taking a long time to load the page? It was so bad, actually, our queries, that we were scanning the entire database for twice on every page load. Don't
wow.
ask that.
Okay. That can get slow.
Yeah, we had two inefficiencies, and so you fix the first thing that you think, this must be the bug, the thing that's add an index here, and then you're like, it's still like it's better, but it's still quite slow, and then you eventually find the second problem. So technically, it was we didn't sleep a lot, and burning through Anthropic credits, and every time. So I don't know if there was a graph at one point. We did almost like build in public. So it's like how many people have run the agent, and the first spikes were at like 10,000, and then things would fall over, and we'd like the virality would die off, and then we fixed things and like spiked at like 60,000 in an hour, and then we were like, oh cool, it's all over. We're on a Friday night. We were like it'd been a few days since it like spiked insanely, and then we were having a team meeting, and suddenly it got the biggest spike ever, and Japan found it, and so overnight, just like went insanely viral in Japan, which they clearly love Twitter and being roasted on Twitter. But it was a great example of like how you can build a prompt that combines external data with like good models. We used Claude 3.5 Sonnet. We actually even had to use Wordware to optimize our prompts because suddenly the cost started to matter. So we even switched to Haiku by like changing the formatting and optimizing the prompt, and kind of initially we got terrible results, and then we could iterate and we got like way better results that are about on par with Sonnet. So it was a great experience, really, really quite fun. And led to a lot of people knowing about Wordware, knowing what Wordware is, and wanting to use it.
Yeah, that's pretty cool. I like the demo there. Yeah, my wife would like it. Getting married to a SQL query. You mentioned burning your Anthropic credits. I was wondering if you guys have experimented with other LLMs, and what were your findings, and why did you settle with Anthropic and Sonnet?
Yeah, so Wordware is LLM agnostic. We basically curate the top LLMs on the frontier of that kind of cost, quality, latency trade-off. So you're often, not always do you want to use the most powerful model, because that's very expensive and very slow. Sometimes you need like much faster responses. Sometimes the unit economics don't make sense. So you want to switch to the cheaper models. And the difference between the models is you kind of get a vibe for them.
Right. And
the general vibe is that the GPT OpenAI models are really good for reasoning and for like logic, and kind of, they're cold, hard, calculating. They will give you what you want, but it won't be nice to read. So you don't want them writing poems. You don't want them giving content for like blog posts and like doing that kind of thing. Anthropic's models are, I guess Claude 3.5 Sonnet V2 came out yesterday. So, this might no longer be true, but they were generally slightly less good at reasoning. But they were much more tasteful on the like their output. You actually wanted to read their output. They could be more creative, more just more readable. And they had I guess context window is another thing. So sometimes you need a bigger context window. That used to be that Anthropic had a bigger context window. Now I think they're sort of on par with OpenAI and Anthropic. But you tend to choose an Anthropic, like Claude 3.5 Sonnet, is better at coding. But then now the O1 model is like probably the best at reasoning, but is very slow because it's got to like do this thinking. So like OpenAI and Anthropic are definitely the models that people use most on the platform. And I think probably most in the world. We also have the Llama models. They're really good if you want something that's a lot cheaper, but also pretty good. And they're less likely to say no. So the OpenAI and the Anthropic models will often say no to things that they don't want to do because of copyright, because of like it's in the slightly more risque category, or it's so that's one reason people use the Llama models. We have the Mistral models. They're also very good for being cheap and fast. They're used less and less now. The Llama models have got better. There used to be like a better version of like Llama 2 was like to use the Mistral models. Now it seems that the Llama kind of 3.2 models are better across the board. That might be a bit biased, so don't take my word as gospel. sorry, a bit underinformed. What else we got? So we have the Cohere models. They're really good because they have an online node, so you can get them to do an agentic web search before they respond. And they're really good at like referencing their like grounding their response on data. So if you ever need up-to-date information, they can be great. There's also the perplexity models, which are just the llama models, but perplexity is data, so the sonar models, which is really, really useful if you're trying to do some like web search. You can just be like, what was the hurricane that happened last week? And most of the models that have been trained, they have a cutoff date, they don't have up-to-date information. So like OpenAI and Anthropic, they'll all just be some cutoff. Whereas if you ask something like perplexity, it will have up to the last. I mean, they refresh this index really, really frequently. So if you ask about the hurricane, it'll talk about like Florida. I think that's right. Yeah, Florida a couple of weeks ago, and it'll actually like talk about the hurricane and give you a grounded answer, which is really useful. And it's a lot faster because it's not doing agentic search; it does like a RAG-based thing. So there's all these trade-offs. I guess we allow you to pick what you want, and it takes a bit of time to understand. We're going to work on making it like educating people. Like all this stuff that I just said should really be in a video or be in a, but it moves so quickly, so it's hard to like.
That's definitely very useful. Like if you want to create a narrow agent, right? Like you want it to be really good at one thing, so you leverage these capabilities that these LLMs have. I think I had way too many questions. I'm sure our audience would like to see some demo, and I know that you have something for us. So maybe you can show us Wordware and how it looks. Yeah,
very keen to show. The one add is the other reason we have all these different models is that often you want to be able to as well balance it within the same flow or within the same agent the qualities and drawbacks of different models. So you'll want to get OpenAI to do some reasoning, and then you'll want to get Claude to like turn that into something that's readable by a user, or you'll want to get Perplexity to do some web search, and then you'll get something that's slightly more meaty to do another thing. But getting started with Wordware, so you can go to wordware.ai and you can click sign in or try for free. It's very easy. I think if I click this, it will take me straight to being logged in. And so you get this dashboard. You can create new projects. You can kind of select from some templates that we have. There's also the explore page that you can use to discover different agents. And so this is a really great place to kind of get started. You can like find these different agents, everything from like the slightly more general autonomous agents, all the way to kind of more narrow kind of like this is finance and legal examples. And then we have a bunch of fun ones. So you can like turn yourself into a Lego figure. And actually this is me and my co-founder, and you can literally just like run them straight away. And this is a model. This is an agent that will like take in this picture of me and my co-founder. It will describe what's going on, and then it will turn that into a Lego minifigure using this kind of image generation. And hopefully this will look like, there we go. Well, both looking kind of nerdy. There's also Lego
awesome.
we could do you later. It's and you can click make your own version. Import those into your own organization. You'll probably just have one organization. I'm just in a lot of our customers' organizations to understand what they're building. And this takes you actually into the editor experience. This helps you, or this is where you build with Wordware. And so you can see exactly what the prompt is. Basically anything up here is just the title and the description. It's not seen by the LLM, and these inputs are not seen. But this is everything from here onwards is the prompt. And you have the concept of a generation. So anything that's blue is an output from an LLM. That always sees the content that comes before it. So every time you see a new blue bit, it will feed in the entire previous context, including any previous generations. That's one thing that tends to trip people up when they first get started is like, what is the prompt for my LLM call? It's actually everything that's currently in the document above it. And it can't see forwards. So if you fork a prompt, if you click the make your own version, you can like iterate, change it. But maybe let's start, take a step back and start from hello world. Like any good programming language, we should start with a hello world. So I can do something very simple, like say hello to @name. If I hit enter, name now becomes like an input variable. And this is just like a templated value that we populated at runtime. So you can kind of think of a Wordware agent or Wordware flow as a function that takes in some inputs and outputs whatever you want to generate. And then we've got the slash command. So anyone that's used Notion, this will be very familiar. It's very familiar to PMs. It's what our customers kind of love, that they can, whilst the technical people love that they can offload a lot of the prompting to the PMs, and the PMs love that they're no longer like blocked by the technical person to actually like iterate on their own. We even had one customer that built a Postgres backend and a React front end so they could free their PM to prompt on their own. And like, it's like a little CMS for prompts. And then that's fine once you've got one prompt, but as soon as you want to do like a chain of prompts, you want to use tools, you want to do logic in the prompt, it all falls apart. And so they found Wordware and they're like, oh my God, this is a savior. But anyway, so with the slash command, you just hit slash on the keyboard, it pops up this little menu. You've got generations. These are outputs from LLMs. You can just be simple freeform generations, or you can do structure generations. This is where you want kind of JSON mode. You want to feed that output into some tool. You want to like render it in some UI with like particular parameters. So I guess we did a structure generation for the Twitter project, and each of these boxes in the Twitter app are like one field in the structure generation, and that way we can easily render the right bits in the right place.
So do you define the do you define the structure of the JSON file? Like, because when you use, let's say, OpenAI and you want to use function calling and you want to use structured output, like, but you have to I see. You're answering my question.
Exactly. So you can define like a full JSON schema. You can have like objects and like lists, and you can have like text, numbers, and booleans. And also on each of the fields, you can give them descriptions like a happy greeting. And so this is, and what you can also do is very quickly switch between the different models. So you can experiment with something tiny like Llama 7B, and then like try like the different better models. So if we try like GPT-4o and I run this and I say like Neon webinar. And so this is going to format the prompts like say hello to Neon webinar. And then we've got this this greeting here that has come from GPT-4o, and because we gave it the prompt inside the or like we gave the guidance inside the structure generation that it should be a happy greeting, it kind of started using emojis and output.
I really like also. Sorry, I was saying like I really like that you can switch models, and especially that I don't have to rewrite, like me as a developer, I don't have to rewrite all the code and change SDKs every time I change a model. And here exactly. It's like I'm doing the same steps. I'm just clicking. I'm one click away from the changing models. It's pretty good.
So it's super easy. I mean, like we can see like running it with Mistral 7B, we get kind of like a very, like it hasn't actually followed the instructions well. It's actually put the greeting as say hello to Neon webinar, which is not what we wanted. We wanted to actually say hello. So here you can have maybe like even things like adding a full stop might be enough. It's so we like you can iterate with these models. You'll tend to find that like different models perform differently. They require slightly different prompts, but you can change the way they run. There you go. Hello Neon webinar attendees from Gemini 1.5 Pro. And that's obviously super simple. You would never bother to deploy this, but you can straight away deploy it as an app. So this is now triggerable from your code base as an API. So you've got this like API docs. You can hit it from your API. It basically is a function that will take in a name and it'll output that greeting. You can also view the little app page, and this is how a lot of people iterate. So they will build their agent or their flow. They'll deploy it as an app, and then internally their team will come in and now I can say, I can now like run it with your name and go, hello, Ralph. So it's a good way to like iterate very quickly. Obviously this is quite boring because it's just a hello world. So maybe let's make it a little bit spicy, and we'll go for something like research at name. And then we'll do a generation. And for this generation, we'll just give it a name. and we'll use Perplexity's model. So we'll use the Sonar large model, and this will hopefully be able to find information about you. We'll then do something like write a funny poem about name, and we'll create the poem. And this will let's use 3.5 sonnet v2 for the poem. I've not tried this yet, so this is the newest model. And then let's now imagine how this person might look and create an image of them. And we can now use other things in the Wordware kind of toolbox. So we can skip through the logic stuff. So this is like looping, branching, calling subflows, and executing code. We can also define like runtime inputs or other inputs this way. And then we can use a bunch of different tools. And so the tool I'm going to use here is the image generation tool. So you can filter it just like Notion, like that. We'll pass in, actually I haven't generated the visuals. So we'll first like create a little description of you, and then we'll pass in these visuals and we'll generate an image. So if I run this and I put in, let me grab your surname from over here, Chebri.
All right, so after being roasted, now I'm going to get a poem.
Now you're getting a poem. So
Thank you so much.
It's finding out information about you. And actually, what I didn't do is I'll get the poem to be read out by 11 Labs. Let's get a British email to read it out. So we'll run this again. And so now it's going to do the search. This is using Perplexity. So you basically get to find out what Perplexity knows about you, which is often surprisingly a large amount.
Scary.
So yeah, and this is just from your name. Often you can also put in like this person at this company.
Right.
I guess you've got a reasonably online profile with lots of different like blog posts and things that you've written.
So
yeah,
we couldn't hear.
Yeah,
I think we couldn't hear the 11 Labs models.
Hasn't read it out yet, so it's
okay.
just like researched you with Sonar. It's read the poem out with it's like I created a poem with Claude 3.5 Sonnet v2. There we go. This is the kind of thing that you get with Claude is like it will caveat, and it'll like it also likes to introduce itself with like, here's a lighthearted poem, whereas OpenAI will just like output the poem and it won't give a caveat of like, please note this is meant to be respectful whilst being humorous. So we've written a description about how you might look. There we go. We've got this is what Flux and
I'll take it. Love it.
5440 think you look like based on all the information. So you're a developer advocate with databases. You've aged a bit, and then
we can't hear it, unfortunately.
Oh, you can't hear it. Oh, that's a shame.
No.
But, it was nicely reading it out in a beautiful English accent.
Nice.
So, but yes, it was just reading out this poem. So it makes it very, very easy to chain a bunch of different things together. And actually, we built an app that does this to make an entire website. So it will do the research. It actually combines two different models for more success. So it uses Command R+ first, and then Sonar Large. It then breaks down your experience and some quotes from you, and it writes some jokes for you. It generates an image, it creates the poem, it reads it out, and then it makes a website, and it will host that website in our CDN. And here's one I made earlier. So it pulled in your various details. It's actually got your GitHub. It found your like Medium page as well. And it kind of gives a little description about you. Also envisage you as a tech advocate. Wrote a poem, which I guess you can't we can't hear, so there's no point in playing it. And there we go. Branches are just a copy or clone of your database. These are quotes from you. But the jokes. Why did the database ready to go broke because he kept losing his keys. They're not very funny, but the cool bit is all of this is fully generated by AI. There's like, and it's repeatable. So this is now an app that can take in a name and output a website.
It's incredible. I'm actually, blown away about how easy it is just to chain those agents. And you just press enter, go to the next line, and add another agent, give new instructions, and you can do that indefinitely. And the result is just incredible. What I like about the interface is how clean it is. So it's very familiar. It looks like Notion, but I like it's just clean and well made as well. So it feels like it's just so easy to create.
It really has been thought from first principles for prompting. Like for example, here we've got a comment, and now it's not possible in code to add a comment inside a prompt because you'd have to write a string, then write a comment, then concatenate that string later on, and then you've got the risk that you don't actually concatenate the string, and it's just really ugly to write prose and write like long form content in a monotyped like editor, and instead of having like hash instructions, we have instructions. If I could type better. So like the formatting looks nice. You can use like all of this gets turned into Markdown when it gets fed to the LLM. So the LLMs actually really like having stuff that is formatted and nice to read. And it's sometimes hard to tell when you've got formatting errors. And the formatting errors really do mess up LLMs outputs. They, if you have something that's not correctly formatted, you've got missing, you've got like a backtick and then no other backtick, they get confused. The attention mechanism has been trained on like generally good data. But this is just I wanted to give you like one more example of like a slightly more advanced agent. And this is an agent that or like a more general agent. It's an agent using the React framework. So it'll basically go through this reasoning and action part where it follows a loop of thought, action, input, observation. And this agent has basically been prompted to write code and run code. It can even web scrape as well. That's cool. This has changed since I last looked at it because it's in our team builds and iterates on these agents. It's been trained to write code and run code, or told to write code and run code to solve the different problems that you might have. So it actually does this thought, action, input, observation, thought, action, input generation inside a loop, and this loop will loop until the next action is done, and then it will based on the action. So the action could be a web search, then it will do a web search with Exa. The action could be running code, and then it will actually execute the code that was run by the LLM. The action might be web scrape, so it will take in the URL to web scrape. And basically every time it will look at the outputs and it will iterate until it gets to an output. I think what's also quite cool here is some of these tools are actually, none of these tools are subflows. So, but you can define your own tools. You can just write a code block that uses a tool and have that deployed. But we'll run this and we'll put in, there we go. What career opportunities are available at Wordware AI? I think this was when we were doing a more career demo, but let's do what's the current Bitcoin price? And this is going to be like a fairly simple question for it to answer. But it basically goes through this loop and it says, okay, I need to find an API that gets the current price of Bitcoin. So I'll do a Google search for Bitcoin price API. It then, it decides Google search is not a valid action, but web search is. I think might be that the prompting has broken since it was last looked at. But it ends up using web search, which is the Exa one, gets the outputs from Exa and decides that CoinGecko is a good choice to use. So it writes the code for CoinGecko, runs that code, and you can see that it's literally evaluating the code that was generated by the LLM, and decides that it's done. And then it gives you this final answer that's the current price of Bitcoin is $65,697.
Brilliant. This is really cool. And I think one of the, as a developer, one of the most underrated feature here is like how easy it is to move from a model to another. I know I mentioned it before, but also like when I see that you can go from text generation to image generation to audio generation models that quickly, where in code you would use so many more lines of code, and that's pretty cool. Yeah, thanks for the demos.
Yeah, we really wanted to remove the friction and bring the important bits front and center. I think even looking at the prompt as it's running and seeing where it's like going wrong is a massive unlock. I realized I made one more demo, and this is just like it just shows the web scraping. So we web scrape Neon, we web scrape Wordware, and then we get Claude 3.5 Sonnet to write a website, and then this calls a subflow. So this is a flow that I made earlier down here, and all this does is take the HTML code or take the output from the LLM, strips away any of the stuff that's not the code. So it'll strip the data between the triple backticks, and save that to our CDN, and then create a website. And this is just like a demo of Claude 3.5 Sonnet. So I run this, it'll scrape Neon, it'll scrape Wordware, and clearly our website takes longer to scrape, more going on there. And it will write some code to make a landing page. And so here's one I made earlier, but basically it made this just from scraping the two websites, and it will link to the different websites. And as you click, it goes, gives you a little bit of confetti, which we love confetti. So
very cool.
Cool.
Yeah.
Well, if you want to get started with Wordware, you can go to wordware.ai. We have a Discord where we're super responsive. We help people build things and help a lot of different companies move faster with their AI development.
That's really cool. I really hope, like, I don't know if we got any questions from the audience, but
we've got a few that have come in, and love the demos. Those were really fun. Got some kudos on that too in there. Just a question for me, and maybe I'll kick this to Ralph first. You guys are here together. I wonder if you can talk a little bit about your sort of story, together. Neon plus Wordware.
Oh yeah, I'll leave that to Robert. He knows much more than I.
Sure. Yeah. So we actually wrote a blog post all about how much we love using Neon. I think Neon aligns very nicely with our philosophy of like iterate faster. And so because they're this serverless Postgres, partly they're like serverless Postgres. So they're like, there's Postgres, they're awesome, and they're serverless, so they can deal with like the scaling up and down really nicely. So we don't have to worry about, provisioning databases and like making sure we can increase the capacity and throughput and things. They just scale. We just we use Neon. So that's one massive headache away. The other thing that I think is huge for developer productivity is being able to have every branch of every ticket that you make, every branch that you create of your Git repository, and then you deploy that, or then you create that as a pull request. That will get straight away deployed as a preview environment. But it also have access to all the production data in it's a copy on write basis. So there's like zero costs to creating all these branches. So every time our developers spin up a new branch, a new PR, they can access all the production data. So if there's a bug that they're trying to fix, they can just iterate really quickly to fix that bug. There's no time and effort spent. The friction is gone. And I think it's one of those things that you wouldn't bother doing if it required even like some amount of time to transfer the data across, apart from for really painful bugs. Whereas what you get to do is you get to run your database migrations against the production database. So you see straight away if your schema migration didn't work, or there was some like edge case of old data that you'd forgotten about that wasn't able to be migrated. And then you can fix that edge case, and when you deploy to production that it's not going to fail. That you've got that extra layer of security, and with zero like mental overhead for the developers. So we're a huge fan of Neon.
Yeah, you mentioned that your entire infrastructure is serverless, right?
Yes.
So
fully
what
serverless.
else do you use?
Yeah, so we host the main application on Vercel. That's that's part of the like fast feedback cycle. We use AWS for hosting some of the more I'm trying to think of the right word, like more infrastructure heavy components. So like the code execution environments, they're hosted inside AWS. And then we also use Cloudflare a little bit. So we use Cloudflare for our execution environment because their durable objects are an incredible primitive for stateful serverless.
Very cool.
Sure.
Yeah,
multi.
Yeah, all over. It's like, what do you use? We use everything that is serverless.
Everything that's done for us, we will use. We don't spend time on infrastructure. Spend time on the differentiator. I think that's true for every business. Focus on the stuff that's going to make your.
Do you host do you have do you use Anthropic APIs, or do you use AWS for that? Do you host your own models as well?
Yeah, we use Bedrock through AWS for the Anthropic models. We use obviously OpenAI directly for OpenAI. And then I guess the open source models, some of them through Bedrock, some of them through Together, some of them directly from, I guess, Mistral. It's a big range.
So it makes
a lot of
so a mix between like hosting your own models and also like using the APIs and.
So we don't host any of our own models. We use inference as a service. So rather than spinning up our own GPUs, trying to like work out the right allocation for different models, and that is a whole headache in and of itself. And I'm sure as we scale even to a very high size, it will be more optimal to use these kind of token as a service providers, where you can start to provision throughput if you want to, and that will save costs. But at the point where people are exploring and changing models, and every week, a different model will be the hot model to play with. That's when,
that makes total sense. Yeah, you're right. Any questions from the audience?
There's another one here. This is kind of an interesting one from Marcus, who's asking: do you think the role of the software engineer will be replaced by a new role? E.g., the Wordware engineer, and should software engineers start learning how to build smart backends with Wordware?
That's a good one.
It's a really good question. I think the software engineer won't be replaced by a Wordware engineer. I think if you kind of look at the kind of unlock that AI gives, every software engineer is now able to do a lot more. So actually, I think there will be more software engineers in the world. But I think there's this other kind of role for analytical people, and it's a little bit like Excel at the dawn of the kind of personal computer, as they started spreads kind of becoming useful. Excel was the tool that most people programmed with. They didn't realize they were programming, and no one kind of called themselves an Excel engineer. But that's effectively what they were. And there's 750 million users of Excel like active at the moment in the world, and there's only sort of 50 odd million software engineers. So I think hopefully there's this role of a Wordware engineer that will be these new people that come to the market to build AI applications to augment their company's ability to kind of automate. I think, we're kind of in a decade of kind of automate or be automated. And so, if you've got to like learn the skills to do the parts of your job that are repeatable and kind of sort of not differentiating, and then really double down on the parts where you're like an expert and like able to differentiate. So hopefully tons of people will be Wordware engineers. They may not think of themselves as engineers, but they will be.
Very cool. We had another question here. Paul was asking about security. Are there any security implications of, using these different agents in combination, and, that kind of stuff?
I think there's always security risk with any system. I would, there's various different things. You don't want to give your agents access to the very low level systems that can break stuff. It's just the same as you don't give your intern access to the bank accounts of your company. And so I think there's definitely a lot about how do you give the right permissions to different agents to perform different tasks. I think the sort of Terminator scenario, or maybe not Terminator, the sort of HAL scenario of I'm afraid I can't let you do that. I think we're a little way off agents that have agency, so to speak. They're given these tasks, but they're very easily stoppable, and they're not going to sort of start inventing their own tasks that are kind of out of the scope of what one would expect. And certainly if they do manage to do that, they probably won't pay attention to it for long enough because,
Yeah, 100%. And also, like, from my perspective, from a database perspective, like, you don't want to give agents like access to sensitive data as well. Like, you don't want to send sensitive data to LLMs. You need to make sure that you're having everything having the right infrastructure, that you're not necessarily using an API. I think that's not good practice. So yeah, I guess like the same applies to all companies out there.
Great. Hey, we probably got time for one more question. There's one here. It's a really nice one. They're wondering, what do you see teams struggling with the most when building AI apps? Or said another way, what advice would you give to teams, looking to build AI agents?
Yeah, well, the number one, I'd say use Wordware. The thing we really do see, and we are a massive unlock for, is this slow feedback cycle. When your engineers are not domain experts, it's amazing how much faster things move as soon as you put the person that knows what good looks like in the driving seat. They're able to like imbue their taste on these systems. It's still a big uplift for just engineering teams alone. But often those engineering teams are building like software engineering agents and they're already domain experts. So it's like it's only a minor lift. And then they have sort of really niche requirements about low level access to certain stuff. So so we think use Wordware. That is going to make you move a lot faster. Like tighten that feedback cycle, put the person that knows what good looks like in the driving seat, and you'll build a better agent in less time.
Yeah, from my perspective, like one of the most difficult things that I have to deal with when I build agents, and I probably will use Wordware. So it's just as you mentioned, the slow feedback cycle and the fact that the temperature varies all the time, and you don't necessarily get the desired output all the time, and you gotta wait every time you test something. So that's why I was talking about the ability of using multiple language models, because sometimes you have to test which ones work the best for your use case, and that is something that can be a little bit challenging when you build agents.
And Robert, before we wrap up, you got into this a little bit, but if people want to get started with Wordware, what do you recommend?
Yeah, head to wordware.ai. That's Wordware like software, WARE. I'm sure you've seen it enough on various different places around. But yeah, go to wordware.ai, sign up, look at the explore page, play with things, and then hit us up. We're super happy to help on Discord, or you can email me, robert@wordware.ai, if you've got any questions, and I'd be happy to help support you guys.
Excellent. And Ralph, any people want to check things out at Neon?
Yeah.
Any recommendations?
Yeah, go to neon.tech, and you can spin up databases in 200 milliseconds. So I really highly encourage you to go and try it out. Now we have auto scaling. I think it's part of the free tier. We have 10 projects. So just give it a spin, try it out, and see how it looks. We have a Discord channel, Discord server as well, where we can find us. You can ask your questions, and see you very soon. Can't wait to see what you guys build. But yeah, thanks, Robert. This was I loved taking the backseat and just learning about Wordware and taking this crash course. It was an amazing demo. Honestly, very impressive product. Thank you so much.
Well, thank you so much for having me, and great chatting and sharing Wordware with the world.
That's cool. I hope less people roast me though.
Well, we'll see. Roast in the comments. Roast in the
comments. Use Wordware to roast in the comments.
Oh yeah. Even better.
All right. Well, thank you, gentlemen. Really appreciate your time today. It's fantastic.
Cheers.
All right.
Bye. All right, and I'm going to let these two guys go and just do the prize drawing. And the winner of the $250 Amazon gift card today is Michael Dunham from Virginia. So congratulations to Michael. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Neon for making this event possible. And thanks as always for attending and for your great questions. That's going to conclude today's event. Have a fantastic rest of your day.